Welcome students. Now we are going to study about alkenes. So alkenes are unsaturated hydrocarbons. Okay, so in this content is what introduction, then isomerism in alkenes, preparation of alkenes, physical properties, chemical properties, and uses of alkenes. So first about introduction. So alkenes are unsaturated hydrocarbons containing at least one carbon-carbon double bond. Okay, so what is difference between alkanes and alkenes? Alkanes are saturated hydrocarbons containing single covalent bonds. It may be carbon-carbon or carbon-hydrogen, while alkenes are unsaturated hydrocarbons containing at least one carbon-carbon double bond. So general formula of alkenes is CnH twice n, while that of alkanes is CnH twice n plus 2. In case of alkenes, n is equal to 2, 3, 4, etc. As it contains at least one carbon-carbon double bond, n is equal to at least 2. Then first member of alkene series, here simple Lewis formula is given CH2 double bond CH2, and for same ball and stick model, in this black ball indicates carbon and white ball indicates hydrogens. Okay, then we are going to study about isomerism in alkenes. Okay, we had studied isomerism in alkanes, and in case of alkenes, more than 3 carbon atoms shows structural isomerism and geometrical isomerism. Now, what is meaning of structural isomerism? It is related with structure. So alkenes with molecular formula C4H8. It is called butene. So structural formula for butene can be drawn in 3 different ways, like this. First formula, straight chain of 4 carbon atoms containing one double bond, and position of double bond is between first and second carbon, so it is called but1ene. Then second isomer, same straight chain, here but2ene, only position of double bond is shifted here. Then branched chain alkene having same molecular formula. See here, 3 carbon atoms are in straight chain and there is 1 carbon as a branch point. So IUPAC name of this alkene is 2-methyl-prop-1-ene. So structure first and third or second and third, these are the examples of chain isomerism which we had studied in case of alkanes. Alkanes मध्ये आपण शिकलोय chain isomerism. Isomerism due to difference in arrangement of carbon atoms in carbon chain. That carbon chain may be straight or branched. Then they differ in carbon chain length. Okay, structure first and second are examples of position isomerism. See here, in first structure formula is but1ene, double bond is present between first and second carbon, and in second structure it is present between second and third carbon. Okay, so these two are position isomers. They differ only in position of carbon-carbon double bond in same carbon chain. Then second type is geometrical isomerism. See, it is related with geometry. Now geometrical isomerism arises due to difference in spatial arrangement of atoms or groups about doubly bonded carbon atoms. काय इथे फरक आहे पहा, तर डबली बॉन्डेड कार्बन ॲटम्सला जोडलेले ॲटम्स किंवा ग्रुप्स याची स्पॅशियल अरेंजमेंट म्हणजे 3D स्पेस मधली अरेंजमेंट यामध्ये डिफरन्स असेल तर जे आयसोमर्स तयार होतील त्याला आपण म्हणणार आहे जॉमेट्रिकल आयसोमर्स आणि फिनोमिनॉन जॉमेट्रिकल आयसोमेरिझम. ओके, तर याच्यामध्ये पहिला जो आयसोमेरिझम त्याला आपण म्हणणार आहे, पहिला आयसोमर आहे टाइप, त्याला म्हणणार आहोत सिस आयसोमर. व्हॉट इज मीनिंग ऑफ सिस आयसोमर? So it is geometrical isomerism in which 2 identical or similar atoms or groups lie on same side of double bond. Double bond च्या एकाच साइडला, फॉर एक्झाम्पल here दिलेलं आहे पहा कार्बन कार्बन डबल बॉन्ड डाव्या बाजूला 2 X atoms आहेत आणि उजव्या बाजूला 2 Y atoms आहेत. So here similar atoms are present on same side of double bond. It is called cis isomer. Then trans isomer. Instead of same side, when they are present on opposite side of carbon-carbon double bond, it is called trans isomer. पहा एक्झाम्पल, वरच्या एक्झाम्पल मध्ये 2 सिमिलर ॲटम एकाच बाजूला आहेत X, तर दुसऱ्या एक्झाम्पल मध्ये एक X लेफ्टला आहे तर दुसरा X राईट. सो 2 सिमिलर ॲटम्स आर or identical atoms are present on opposite side of carbon-carbon double bond, then it is called trans isomer. See here, example, but2ene or 2-butene, cis-for and trans-for, 2 similar atoms, hydrogens or methyl groups. They are on same side. 2 methyl groups are on upper side, 2 hydrogen atoms are present on lower side. It is called cis. And when they are on opposite side, it is called trans. Okay. Now they differ in their physical properties. Chemical properties are same, but physical properties are different. See here, boiling point of cis but2ene is 277 Kelvin, while that of trans 274 Kelvin. So trans form is more stable than cis form. Due to different arrangement of atoms or groups in space, these isomers differ in their physical properties like melting point, boiling point, solubility, etc. Then we are going to study about preparation of alkenes. So first method for or industrial sources of alkenes. Then we are going to study methods of preparation of alkenes. In that, elimination reactions. In elimination, dehydrohalogenation of alkyl halides, dehydration of alcohols, and by dehalogenation of vicinal dihalides. Okay. Then second type, addition reactions. And in industrial sources. So first we'll start with industrial sources. Most important alkenes for chemical industry are ethene, propene, and buta-1,3-diene. These are the industrially important alkenes. So alkenes containing up to 4 carbon atoms can be obtained in pure form from petroleum products. Okay. Ethene is produced from natural gas and crude oil by cracking process. Then we are going to study about methods of preparation of alkenes. In that, first, elimination reaction. Now this elimination reaction is also called 1,2 elimination reaction. Now why it is called 1,2 elimination? Because reaction in which 2 atoms or groups are eliminated or removed from adjacent carbon atoms. Adjacent means शेजारी शेजारी, आणि त्यामुळे त्यांच्या पोझिशन्स कशा येणार आहेत, शेजारी शेजारी म्हटलं की 1,2. So therefore this reaction is also called 1,2 elimination reaction. See here, in case of elimination reaction, carbon adjacent carbon atoms, suppose 2 different atoms X and Y, they are attached with these adjacent carbon atoms. Then by removal of XY, 1,2 elimination, formation of sp2 hybridized carbon, that is alkene, doubly bonded carbon, take place. And in this case, it is sp3 hybridized carbon. So in this elimination reaction, first elimination is dehydrohalogenation of alkyl halide. D means to remove, hydro means hydrogen, and halogen. Okay, so hydrogen and halogen from adjacent carbon atoms are removed here to form corresponding alkene. So here dehydrohalogenation, removal of hydrogen and halogen from adjacent carbon, and carbon carrying X is called alpha carbon, and therefore hydrogen from adjacent carbon called beta carbon, and it is removed in this reaction. Therefore this reaction is also called beta elimination reaction. Okay, जे अल्फा कार्बनचा हॅलोजन रिमूव्ह होईल आणि बीटा कार्बनचा हायड्रोजन रिमूव्ह होईल, आणि म्हणून या रिएक्शनला काय म्हटलेलं आहे, बीटा इलिमिनेशन असंही म्हटलेलं आहे. Dehydrohalogenation suffers from the disadvantage that hydrogen can be eliminated from the carbon on either side of alpha carbon bearing dehalogen. म्हणजे समजा त्या हॅलोजन कॅरिंग कार्बनला दोन शेजारी जर असतील लेफ्ट आणि राईटला, तर दोन्हीकडचे हायड्रोजन्स काही काही प्रमाणात रिमूव्ह होतील आणि आपल्याला मिक्सचर मिळेल. ओके, सो हियर phenalkyl halide. Now what is process here? Phenalkyl halide is boiled with hot concentrated alcoholic solution of strong base like KOH or NaOH. Alkene is formed with removal of elimination reaction, removal of halogen and hydrogen. See here, general formula is given CH3CH2X. Okay, now this one is halogen carrying carbon, which is denoted by alpha, then adjacent carbon by beta. When it is heated with alcoholic KOH, removal of X and H from adjacent carbon atom take place, forming corresponding alkene. Okay, here ethene, formation of ethene take place. One more example, 2-chlorobutane. Now here halogen carrying carbon represented by alpha and adjacent carbon atoms are here. Two adjacent carbon atoms, one is called beta, then second is also beta. Then it is heated with alcoholic KOH. Now here what happens, mixture of along with halogen chlorine, here removal of this one hydrogen atom can take place, or this one hydrogen atom will be removed. Now when hydrogen of this carbon is removed, formation of but1-ene take place. And when along with chlorine removal of this hydrogen take place, formation of product but2-ene take place. Now here proportion of products is but1-ene is 20%, while but2-ene is 80%. So here major product is but2-ene, and it is proved by Sedgwick rule, or it is proposed by Sedgwick rule. In dehydrohalogenation, preferred product is the alkene that contains greater number of alkyl groups attached to doubly bonded carbon atom. म्हणजे आताची जी रिएक्शन आपली झाली आहे त्यामध्ये अल्कीन आपल्याला 80% मिळालंय but2-ene. तर हे कोणतं अल्कीन आहे, तर ज्याच्या डबली बॉन्डेड कार्बनला जास्तीत जास्त अल्किल ग्रुप्स जोडलेले आहेत. असं इथं but2-ene आहे, but1-ene ला कमी अल्किल ग्रुप्स जोडलेले आहेत. ओके, आणि सेझेफ रूल नुसार इथे आपल्याला प्रोडक्ट but2-ene हा काय असणार आहे, मेजर प्रोडक्ट असणार आहे. नाउ हियर dehydrohalogenation of alkyl halides. In case of alkyl halides, order of reactivity is like this: tertiary greater than secondary greater than primary. Okay, then formation of alkenes, order of reactivity is again like this: R2C double bond CR2, means here this one is most substituted doubly bonded, is more stable than tri-substituted. This one is tetra-substituted, tri-substituted, di-substituted in these two isomeric forms, and this one is mono-substituted. Okay, so this is order of formation of alkenes. More substituted alkene will be major product. Now stability of alkenes is again same as above. More substituted alkene is more stable. Then second reaction is by dehydration. Second elimination is dehydration of alcohols. D means to remove, hydrate means water. So removal of water here. Now for removal of water, alcohols are heated with sulfuric acid. When elimination of water molecule take place, and this reaction is catalyzed by acid, in presence of acid. Now exact condition of dehydration depends upon type of alcohol. So here again removal of OH group and hydrogen from adjacent carbon atoms take place. So same like dehydrohalogenation, this reaction is also called beta elimination reaction. Okay, for example, now here general reaction is given: OH carrying carbon, alpha carbon, and next beta adjacent. When it is heated with concentrated sulfuric acid, removal of OH and hydrogen, formation of water take place. So here water is removed from alcohol molecule and formation of alkene take place. Then Again here order of dehydration. In case of alcohols, tertiary alcohols easily dehydrated than secondary, and secondary are easily dehydrated than primary. See here formula for tertiary alcohol, general formula, greater than secondary alcohol and secondary greater than primary alcohol. Okay. For example, here CH3, CH2, CH2OH. Okay, and butyl alcohol or butan 1OL. Here condition is 75% sulfuric acid at 413 Kelvin. Formation of alkene but 1-ene. See here removal of OH group and hydrogen from adjacent carbon atom and formation of alkene but 1-ene plus water liquids. Then when here alcohol is secondary, see this one is primary, this one is secondary, same molecular formula, isomer of this alcohol. This one is butan 2OL. Condition, see here condition is different, 60% sulfuric acid, 373 Kelvin, and here mixture of two products, but 2-ene. First product is but 2-ene and second is but 1-ene. So along with this OH group, hydrogen of this carbon can be removed or this carbon can be removed. Now this carbon carries less number of hydrogen atoms. So according to Selzeff effect, this hydrogen will be removed preferentially, forming but 2-ene as a major product and but 1-ene as a minor product. Then next example of tertiary alcohol. See here condition, difference in condition is 20% sulfuric acid, 363 Kelvin. आता आधीच्या याच्यामध्ये आपण सांगितलंय की ऑर्डर ऑफ डिहायड्रेशन कशी आहे. टर्शरी अल्कोहोल्स are more easily dehydrated than secondary alcohols and secondary alcohols can be more easily dehydrated than primary alcohols. इथं तुम्हाला कंडिशन्स पाहून लक्षात येईल की टर्शरी अल्कोहोल असेल तर सल्फ्युरिक ऍसिड फक्त 20% आहे, टेम्परेचर 363 आहे. तेच जर का सेकंडरी असेल तर 60% सल्फ्युरिक ऍसिड लागतं आणि टेम्परेचर 373 लागतं, आणि प्रायमरी असेल तर 75% सल्फ्युरिक ऍसिड आणि 413 केल्विन टेम्परेचर लागतं. आता इथे टर्शरी ब्युटिल अल्कोहोल किंवा 2-मिथिल प्रोपान 2OL याचं डिहायड्रेशन केलं तर आपल्याला एकच प्रोडक्ट मिळतो, 2-मिथिल प्रोप 1-ene बाय रिमूव्हल ऑफ वॉटर. देन नेक्स्ट dehalogenation of vicinal dihalides. Now dihalides are classified into two types, vicinal and geminal. Okay, so vicinal means when two halogen atoms are attached to adjacent carbon atom, it is called vicinal dihalides. And geminal, when two halogen atoms are attached to same carbon atom, it is called geminal dihalides. So from vicinal dihalide by removal of two halogen atoms from adjacent carbon atoms. Okay, here two halogen atoms are attached to adjacent carbon atoms and these two halogen atoms are removed. So process is dehalogenation. D means to remove, halogen. So dihalide in which two halogen atoms are attached to adjacent carbon atom called vicinal. Now process is here, vicinal dihalide on heating with zinc metal, it form alkene. See here general reaction is given. Two halogen atoms are attached to adjacent carbon atoms. When it is heated with metal zinc, zinc removes these two halogen atom, forming zinc dihalide as a byproduct, and remaining is alkene. For example, CH2Br, CH2Br. Okay, 1,2-dibromoethane. Vicinal dihalide plus zinc, it gives corresponding alkene. Ethene, CH2 double bond CH2 plus ZnBr2. Then one more example, 1,2-dibromopropane plus Zn gives next higher member of alkene series, propene. Then addition reactions. By addition reactions, in this addition reaction, carbon-carbon triple bond of alkynes can be partially reduced to a double bond with calculated quantity of dihydrogen in presence of Lindlar's catalyst. Now Lindlar's catalyst is nothing but palladium, palladized charcoal deactivated partially with quinoline or sulfur compound. Okay. Now in this method, cis isomer is obtained by this method. See here, general reaction is given. Alkyne RC triple bond Cr plus hydrogen in presence of palladium, charcoal, quinoline, formation of cis isomer. Here breaking of one carbon-carbon bond and formation of alkene. पहा इथे अल्काइन मध्ये 3 डबल ट्रिपल बॉन्ड आहेत. ट्रिपल बॉन्ड त्यामधला एक बॉन्ड ब्रेक होईल आणि डबली बॉन्डेड कंपाउंड तयार होईल अल्कीन. पण इथं महत्वाचं काय आहे तर लिंडलर्स कॅटलिस्ट वापरायचं. ओके. Trans alkene is obtained from alkyne by reduction with sodium in liquid ammonia. पहा जर आपल्याला ट्रान्स प्रॉडक्ट मिळवायचं असेल तर कंडिशन काय आहे, सेम अल्काइन आपल्याला फक्त सोडियम लिक्विड अमोनिया बरोबर रिएक्ट करायचंय, आपल्याला प्रॉडक्ट मिळेल ते अल्कीनच मिळणार आहे, फक्त हे ट्रान्स मिळेल. Then we are going to study about physical properties of alkenes. So in physical properties, first property is alkenes are low boiling, having low boiling points, and it increases with mass. With increase in molar mass, boiling point goes on increasing. Then about straight chain alkenes and branch chain alkenes. Branched alkenes have lower boiling points, and straight chain alkenes have higher boiling points. Then about density. Density of liquid alkenes is less than that of water. They are slightly polar compounds. Okay, alkenes are slightly polar. Then pi bond, carbon-carbon, double bond is present in case of alkenes, and in that one bond is called sigma and second is pi. So pi bond is polarizable. Okay, so instantaneous dipole-dipole interaction occur in case of alkenes. So alkyl groups are electron donating groups towards pi bond. So many have a small dipole moment. This is about physical properties. And then we are going to study about chemical properties. See here some physical properties. Melting points and boiling points of alkenes are given. Comparison साठी हे आहेत पहा. With increase in molecular mass, म्हणजे इथीन, प्रोपीन, ब्यूट 1 ENE, पेंट 1 ENE, जसं कार्बनची संख्या वाढत जाईल मोलिक्युलर मास वाढत जाईल, आणि मोलिक्युलर मास जसं वाढत जाईल तसे त्यांचे बॉइलिंग पॉइंट्स काय झालेले आहेत, वाढत गेलेले आहेत. ओके, हे टेबल तुम्हाला काय दाखवत आहे, बॉइलिंग पॉइंट वाढत गेले. आता इथे तुम्ही सिस आणि ट्रान्स जर का पाहिलं तर सिसचा बॉइलिंग पॉइंट हा जास्त आहे, ट्रान्सचा कमी आहे, बिकॉज ट्रान्स इज स्टेबल. ओके, तेच तुम्ही आयसोब्युटायलिन पहा, ब्यूट 1 ENE आणि आयसोब्युटायलिन मोलिक्युलर मास सेम आहे, सिस ब्यूट 2 ENE, ट्रान्स ब्यूट 2 ENE, molecular mass is same but their boiling points are different. Their boiling points are different. Okay, so branch chain alkene, it has lower boiling point than straight chain alkene. Okay, so this is about physical properties of alkenes, and then we are going to study about chemical properties of alkenes. So in chemical properties, alkenes are more reactive than alkanes. Our reason is due to presence of double bond. Okay, so they undergo electrophilic addition reaction. Type of reaction is addition reaction, and here reagent is electrophile, electrophilic addition reactions. Okay, so different reactions of alkenes are given below. Addition of dihydrogen, hydrogenation, then second in this catalytic hydrogenation, ethene plus hydrogen in presence of platinum or palladium, addition of hydrogen across carbon-carbon double bond take place, forming alkane, saturated compound alkane is formed. Then addition of halogen. Okay, this reaction is called halogenation reaction. So alkenes are converted into corresponding vicinal dihalide by addition of halogen. See here, addition of halogen take place across double bond. डबल बॉन्डच्या ठिकाणी ऍडिशन होणार आहे. एक हॅलोजन ऍटम पहिल्या कार्बनला जोडला जाईल, दुसरा हॅलोजन ऍटम दुसऱ्या कार्बनला जोडला जाईल. ओके, आणि जे तयार होईल ते डायहलाइड काय असेल, विसिनल डायहलाइड असेल. ऑर्डर ऑफ रिएक्टिव्हिटी इज आयोडीन जनरली fails to react. Okay, so reaction with chlorine is given here. Ethene plus chlorine in presence of carbon tetrachloride solvent at room temperature. Addition of halogen across double bond take place forming 1,2-dichloroethane. Then addition of bromine is useful test for detection of carbon-carbon double bond in unknown compounds. Now, why it is used as a test to detect double bond? Because red-brown color of bromine rapidly disappears in presence of carbon tetrachloride solution if carbon-carbon double bond is present in that compound. So, this test can be used for detection of carbon-carbon double bond. See here, example is given: propene plus bromine. Bromine color red-brown, as it contains double bond, formation of 1,2-dibromopropane, and this 1,2-dibromopropane is colorless. Okay, so this test is useful for detection of carbon-carbon double bond. Then addition of hydrogen halides or hydrohalogenation. Addition of hydrogen as well as halogen atom. So addition of hydrogen halide like HCl, HBr or HI convert alkenes into corresponding alkyl halides. Okay, पहा इथं डबल बॉन्डच्या ठिकाणी HX ची ऍडिशन होईल आणि तयार होईल अल्किल हलाइड. हायड्रोजन ऍटम एका कार्बनला जोडला जाईल आणि हॅलोजन ऍटम दुसऱ्या कार्बनला. Now, order of reactivity of hydrogen halide is HI is most reactive than HBr. HBr is more reactive than HCl. Okay. Now, in this reaction, addition of reaction of HBr to symmetrical alkene, for example, ethene plus HBr, it gives only one product, bromoethane. Fine. If alkene is unsymmetrical, if alkene is unsymmetrical like propene, then it gives two products. One product is 1 bromopropane and second is 2 bromopropane. See here, addition of HBr across double bond. If hydrogen atom is attached to this carbon and bromine to second, then formation of 1 bromopropane. And if hydrogen is attached to this carbon and bromine to first carbon, then formation of 2 bromopropane. So here mixture of two products A and B is obtained. Now in this, 1 bromopropane is minor product and 2 bromopropane is major product. Okay. Now this is proved by scientist Markovnikov. So we are going to study here Markovnikov's rule. Statement of Markovnikov's rule is when an unsymmetrical reagent like HBr in our reaction is added to unsymmetrical alkene, for example propene in our reaction, the negative part, that is Br or X of the reagent, gets attached to the carbon atom which carries less number of hydrogen atoms, and hence according to Markovnikov's rule here, 2 bromopropane is the major product because negative part will add to that carbon carrying less number of hydrogen atoms is CH. Okay, so 2 bromopropane is major product. So this is about addition of HBr to unsymmetrical alkene. Then we are going to see anti-Markovnikov addition or peroxide effect, which is also called Kharash-Mayo effect. Now, if addition of HBr to unsymmetrical alkene in presence of organic peroxide, if same reaction is carried out in presence of peroxide, it takes place opposite to Markovnikov's rule, in opposite orientation to that suggested by Markovnikov's rule. For example, same propene plus HBr in presence of benzoyl peroxide. Here formation of 1 bromopropane takes place. Now, in absence of peroxide, 1 bromopropane is minor product, but in presence of peroxide, it is major product, which is called peroxide effect or Kharash-Mayo effect. Then second example is 2-methyl-prop-1-ene plus HBr in presence of benzoyl peroxide. See here, product will be 1-bromo, 2-methyl-propane. So this is about Markovnikov's rule, and then we are going to study addition of sulfuric acid in next lecture.